Very good morning to everyone. In this lecture, EC8791 Embedded and Real Time Systems, Department of Electronics and Communication Engineering. In previous session, we are going to discuss the real-time operating system using the kernel operating system. That is a kernel architecture functions and how to implement and how to execute the different environmental platforms. Now today we are going to discuss the Drawin. It's one of the kernel open source project operating system. So the architecture of this Drawin and operating system X is composed by several architectural components. These components from the kernel environment. So the operating system basics, it is a bridges between the user application, task and system resources. The operating system manages the system resources and make it them available to the user application task. The computing system is collection of the different input output subsystem working and storage memory. The primary function of the operating system, it make the system convenient to use the organizing and managing the system resources efficiently and correctively. Then we have to move to the kernel. The kernel is a core of the operating system and it is responsible for managing the system and the communication among the hardware and also the system services. Kernel act as a abstraction layer between the system resources and user application. The kernel consists a set of system library of services for general purpose operating system. The kernel contains different service for handling the management. So number one, the process management. The managing the process or task. It is a setup the memory space for process load program code into the space of memory and scheduling and managing the execution of the process and setting up and managing the PCB board and how to inter-process communication and system synchronization process termination and deductions. So also there this is a process management system in kernel operating system. Then the second one is it is a primary memory management system. It is a memory. The memory management system of unit kernel is responsible for keeping track of which part of the memory area is correctly used by which the process of embedded computing system and it is allocated and deal the location in the memory spaces. So the next one is a file system management. The file is a collection of related information. A file would be a program, 10 files and image files and word document and audio and video files, etc. The file system management service of kernel is responsible for creation and deletion of files. The creation and deletion and alteration directly, it is save the file in secondary stage memory management. It is providing the automatic allocation of the spaces and providing the flexible naming of conversion for the files. So the next one is input and output system management. The kernel is responsible for routing the input output request coming from different user application. The direct access of input and output device are not allowed. We can access the input and output the device through the operating impose the kernel. So the dynamically update the available devices and the device manager of the kernel is responsible for handling the input and output related operations. The kernel task to the input and output device through the device drive. This is responsible for loading and unloading of the device drive, exchanging the informations. Now the fifth one is secondary storage management. The secondary storage management deals with secondary storage memory device if any connected to the system The main memory is a functions. The secondary storage management service of kernel deals with the disk storage allocation and the disk scheduling, and also the pre-disk space management system. Then what is a real operating system? A real operating system is an operating system that guarantees a certain capability within the specified time constraint. An operating system is a system program that provide an interface between the application program and the computer system. The application where dependently that is a certain task will finish before a particular deadline is just as obtaining the correct result. Then beside the meeting deadlines of real-time operating system must also be able to respond the predictable to unpredictable event and process multiple event consequently. A real-time operating system is a computing environment that react to the input with a specified time. The real-time deadline can be so small that system react the appearance instantaneous. So the real-time computing has along with also be used, however, to decide how to slow real-time output that has a longer but fixed at a time limited. So in this session, we are going to discuss the real-time operating system. Now we can move to the learning the difference between the real-time and the standard operating system. Is as easy as imagining yourself in your computer game. Each of the action you take in the game is like a program running in that environment. A game that has a real-time operating system for it environment can feel like an extension of your body, because you can count an specific lag time. The real-time kernel, the heart of the real-time operating system, and the heart of the every operating system for that matter, is the kernel. A kernel is the central core of an operating system, and it take care of all the operating system job, the booting, task scheduling, stand functions libraries. In an embedded system, frequently the kernel will boot the boost system, initialize the port of the global data items. Then it will start the scheduler and instantaneous or any hardware timer that need to be started after all the kernel basically get dumped out of the memory for the library functions. And the scheduler will start the run under the child task, the standard functions library. In an embedded system, there is rare edge-free memory spaces. So the basic kernel services, the kernel which is a major part of an operating system that provides the most basic service to apply the software running of a processor. The real-time operating system provide an abstraction layer that it hits the application software, that the hardware details of the processor upon which is the application software will run. Then the scheduling in typically designed a task as a 3 states: running, ready, and blocked. The running is executing on the CPU, and ready to be executed, and waiting for an event. That is the input and output for examples. So in this session we are discussing the real-time operating system in the architecture kernel. Thank you for watching this video.